I've changed the index action around a little bit so we can get a better understanding of how async and await are working inside of this controller action. What I've done is I've created wrapper methods called getHeadlineAsync and getCurrentTemperatureAsync that are async method themselves, and they're going to be responsible for instantiating the weather service and awaiting the result of the call to get the current temperature. Now, this is not typically something that I'd want to do. Specifically, I wouldn't want to create async methods where I'm passing my model around. I would rather have these methods return a task of int or a task of double, grab that result back in the primary action and assign it to the model myself. I don't like having that side effect inside of these methods, but this is just for demonstration purposes, and it makes it easier for us to log when these particular methods are starting and when they're finishing and what thread they're on. So currently, this is how the application is structured, and I have it built. Let's just go in and run it in a browser, and the results might be surprising unless you picked up on a subtle bug that's here. So when the results display, we do not have a news headline, we do not have a current temperature, and it only took 27 milliseconds to render, and there was only a single thread that was seen in the index action, getting the headline, getting the weather, and finishing the thread. So what happened here? Well, the MVC runtime knew it had to run the index action, so it picked up a thread and told it to invoke this method. It came in and it started to get the headline asynchronously. And when it hit this line, it said, oh, I need to wait for this task to complete. So I'm going to suspend execution at this point in time. And I'm going to jump back up in my call stack and go to the next line of code, which is get current temperature async. So it comes into this method, instantiates a service client. It finds it has to await another task result. So it suspends execution of this method, and it is still free now, so it can jump back up here, add this finished action, and then return a view. So at that point, even though we had two methods suspended out here, as far as the MVC runtime was concerned, we produced an action result. So it took that action result and rendered a view, but of course the model wasn't completely built yet. The problem was that we never waited for these other asynchronous operations to complete, and that's why we again have a C# compiler warning that you have an async method without an await operator. So if I just put await here, then what we'll be doing is as soon as we call that method, we're going to wait for the result. We're going to wait for the task that's inside of here to complete. So now if I do a build, then as soon as that completes, I should be able to refresh the browser, and we should see some different results this time, and we should actually get some results in our view. And here's the final results. So we now have a news headline, we now have the current temperature because we waited for those results to get set in the model. And we can also see that we started a lot of these actions on thread 119, and we finished on 120. That's just the way it turned out with the thread scheduler. And what happened behind the scenes this time is that when the thread came into the index action and it called in to get headline async, it also suspended execution at that point and waited for that result. The thread itself might have jumped back into the MVC runtime to do different work, but at some point it picked up where it left off after waiting for those results to be computed. So the other thing to notice about this, we're still doing these operations in serial, so the elapsed time to render was still over 4,000 milliseconds, and that's because we're waiting for the headline call to complete before we go and try to get the current temperature. There's a different way we could do this if we wanted things to operate in parallel, and that is I don't want to await as soon as I call get headline async. Instead, I could say that we could store this into the headline task variable, and that gives me a reference to the task that gets built by get headline async. And instead of awaiting get current temperature, I'll also assign that into a task variable. And now what I could do is I could say await headline task and await temperature task, or I could also combine those together by saying await task.whenAll. So in other words, when all of these complete. And inside of here I can list multiple tasks. So I could say please wait on the headline task, and please wait on the temperature task. And what task.whenAll essentially does is it returns another task that represents the combined efforts of all that outstanding work. So we're going to await for both of them together. But the important part here is that I'm kicking off get headline async, and I'm kicking off get current temperature async and I'm not waiting until both of those tasks have started running. So now when I do a build and I refresh the browser, we should see the time to render reduce considerably. So let me open up the browser. We'll do a refresh. And you can see we still produce the same results. Notice the elapsed time to render has dropped down to just over 2 seconds, or 2100 milliseconds. And we have a number of different threads executing inside of all these different operations. So this is putting things in parallel. I don't want to await anything until after I've kicked off all those asynchronous tasks. They can happen on background threads. I'll await all the results and put the model together. So async await doesn't necessarily mean that you'll be running on a background thread. Doesn't necessarily mean that you'll be running a bunch of different things in parallel. It all depends on how you structure your code and where you put the await keyword.